So, welcome to the first Astute Engineer podcast.
Thank you very much for having me.
Many years ago, we used to market Astute by name, Astute by nature. And it's interesting. It's intelligent, bright, sharp, having insight and perception. That's me. Why don't you introduce yourself?
Oh, you know me well enough, but those watching and listening may not. My name's Simon Brennan. I'm the Semiconductor franchise manager within Astute, a new role that we've actually announced in the last fortnight. So it's exciting for me. There's lots of change. A team that we've got partially in place and we're adding to all the time. So it's an exciting time in Astute.
So how long have you been in the industry then?
I've been in the industry now for about 7 years.
Have you really?
Yeah.
Big head of hair when you started?
A full flowing locks down to my shoulders. No, not quite. It was well receded and a strong gust of wind did for it, I'm afraid. So I was previously with an SSD and DRAM manufacturer, Transcend.
Yep.
I was there for 4 years and then I've been with Astute for 3. And I will say I joined here with hair.
Yes.
It didn't last that long though.
It was interesting. I mean, I obviously knew you from back in the Transcend days and we knew how good you were, not just with the technical side, but with the customer interaction. But the market's changed. Since you've been in the marketplace, it's changed. But since you've been at Astute, things have changed. Where do you see it trending? Where's the semiconductor industry trending now?
I mean, all the noise, everything you hear in the market at the moment is around AI and what's required to make AI work. So the infrastructure there, the vast amount of graphics processing required, and effectively just compute power that's needed at a server farm level. That's driving the market, and it always has done, and it will continue to. The portion that we actually operate in is a very, very small part of the market compared to where the big primes are, the Samsungs, the Microns of this world. They obviously do what they do very well, and we never look to go toe-to-toe with guys like that. But the markets and the customers we operate with have slightly different needs, even though the shape of the market is dictated by the bigger trends, if that makes sense.
Yeah, I get that, and it's difficult to compare with the tier ones, but you've introduced some very niche AI tech and manufacturers. What do they bring that's different then?
So what I was talking about there is really the supply of semiconductors. So that demand to keep these server farms online, up and running, which is really HBM, high bandwidth memory.
Yep.
So that's the latest generation that can deal with graphics processing in the volumes that it needs to. The world that we operate in is actually probably 3-4 years behind what you might consider the cutting edge of the market, certainly in DRAM and memory, just because of the customer's requirements. But more broadly in the market, and what we bring to it with our new lines is the ability to do that high-level processing at the edge. So you hear the term AI, the world we operate in and our customers operate in is edge AI. So it's the ability to have that high-power compute processing on location, in vehicle, on platform. You hear the talk smart cities. It's on location, so distributed computing instead of doing it all centrally.
Okay, I kind of got the picture, but you've got some niche manufacturers. We've always played in the high-end marketplace.
Yeah.
So we're now looking into the Internet of Things, smart cities, bringing a kind of different, innovative approach to bring startups through. How are you actually bringing something different? I'm an engineer. I know the big players and I know who's consuming the market, but what are you bringing different then?
Okay, I'm with you. So the lines that we've got a combination of experienced companies with pedigree. Innodisk to be a prime example, one of our biggest memory lines. But then we're also bringing new names to the fore. Companies like Leaf Semiconductor, which is an IoT-focused 32-bit microcontroller. And that's about having your compute power, as I say, on location at the edge. And an example would be a smart doorbell that's recording footage when there's a movement sensor triggers it, turns on the system. Of course, they're battery powered in most cases. That battery might need to be changed every 2 weeks. But what this does, it works at low power. So when you get an event, a motion capture or a motion sensor triggered, so a leaf blowing past, a leaf, not a leaf, or a cat walking past, that microcontroller will kick in and actually analyze, is this a person I can see? Is it a human face? Do I need to turn on the recording part of the system and actually take note of that data, send it through to somebody's smartphone or record it and send it to the police if it looks like criminal activity or there's someone in an area they shouldn't be. That world, so actually being able to do that at low power, at relatively low cost, at the edge is proving to be one of the biggest demands, certainly for the industrial and IoT market.
And these manufacturers, I mean, are they being impacted by the tariff war? I mean, we're going back over it again. We're reading everything in the press. Not all of it's real. Let's be clear on that.
Yes.
But how's that going to impact?
It's very difficult to say. I mean, if anyone tells you they know the answers, they're lying.
You don't have a crystal ball then?
No, unfortunately I do not. If I did, I might have retired a few years ago on the back of, say, some NVIDIA shares. But,
yes, quite.
Alas. Really, the manufacturers out there that have manufacturing in, let's say China, which is where a lot of the tariff restrictions are going into place. And actually, who knows what's going to happen with the geopolitics, but that could well extend to a lot of other countries, with some of the bigger nations looking to nearshore or onshore their manufacturing. I see that as they've got to make sure they've got the contingencies in place to deal with these tariffs as and when they kick in. I think there's going to be a trade between nations, and we've seen it already with I think Canada and Mexico saying, in fact, if you're going to put tariffs on us, the US will put some back on you, and then it mellows.
This is a child-friendly podcast, so please watch your language. I know what's coming next. I mean, the tariffs, no one knows what's going to happen. We saw the initial impact from the first Trump administration, but then we got hit with COVID, and I think everyone in the world was disabled. But, I mean, this will it actually have an impact on the growth in our industry?
I think an impact maybe, but an opportunity I look at it as, because a lot of those server farms, are in the US, let's say, because they have to have the compute power relatively locally. Their supply chains are going to change enormously. And what that actually means is, means as if I know, but I expect is the markets actually in Europe are probably going to have a more ready supply of componentry that we would otherwise struggle with. Because those who would be buying it are all of a sudden buying something else. And the wafer plants in, wherever they are, but generally in Asia, are still there. They're still producing componentry, and they need people to sell it to.
Well, you touched on it earlier about how DRAM plays a big part in this. I think it was Trendful. I'm reading yesterday, DRAM prices dropped 10%. I mean, DRAM's a good barometer of where pricing is.
Yeah.
We've still got oversupply. Yeah, we're still recovering from COVID, global shortages. Now we're in oversupply. So how do we bring something different, or how does your team bring something different to the engineer that doesn't think he's got a problem today, but it's coming?
Yeah, very good question. And that it's an education piece. It's letting them know we're there and available to ask these questions to. And in that case, I'd suggest that, HBM is the driving force, and the big names out there are having to focus their efforts and their resources in supplying that market. And for us, we're then seeing that manufacturers like Intelligent Memory, who focus on the legacy, the long-term availability. I mean, we mentioned we work in the high reliability market. In a lot of cases, when you're doing a high reliability design, say for aerospace or medical, you could be 5 years easily just designing and testing. So those components you've designed in are already obsolete by the time you've got a functioning platform. And what we want to do is just educate them. And it's not don't use those guys, they're no good. They're the market leaders. They know exactly what they're doing, but there's an alternative out here that actually can act as a backup for you. I used the word earlier, a contingency plan, second source alternatives. And come and talk to us. Find out what we do. Find out what we can offer.
Okay, so you don't have a smorgasbord of manufacturers, but you've got some nice spread of lines.
We absolutely do. Yeah.
Where's your gaps? What are you looking technology-wise, or you trying to bring UK manufacturing, European?
I think we see that from a few customers. The territory side of it is that second source alternative is, and supply chain security comes from having non-Far Eastern manufacturers. It's clear that the semiconductor industry relies heavily on Taiwan, and it's happening in North America, but we're starting to see it a little bit where at least people are developing fabs, and okay, they can't necessarily compete with the economies of scale with Taiwan or China, but at least have the opportunity for an alternative to be made in Europe. So you know that if that supply chain changes, and I know we're all hoping it doesn't, then you've got an opportunity or somebody else you can turn to nearer to you.
Yeah, I think whatever happens in Taiwan, certainly out of our control.
Absolutely.
But, the Semiconductor Chip Act was set for a reason, to protect against the vulnerability of so much reliance on the Asian market and Taiwan in particular. But the UK market, what impact has the Semiconductor Chip Act and investment here? How have you seen that? Have you seen any?
Not a huge amount, if I'm honest. Not from my perspective. More broadly in the semiconductor, which I've only really just moved to. So I'm sure some of my new lines or part of the group's lines will correct me on that. But from a memory perspective, not so much.
So who would be the largest memory manufacturer in Europe? Are there any left?
I mean, it depends how you define memory manufacturer, because the wafer itself, if we're talking about NAND and DRAM, and they're the two biggest commodities out there, they're still heavily reliant. And it's not just Taiwan. There's Japan, there's South Korea that a huge amount is coming out of, and they're more stable. I'm not sure I can answer your question in European off the top of my head. Certainly there's the investment we're seeing is more towards South America, where potentially the labour cost is a little bit lower, but there's a growing level of expertise, and it's a bit more immune from some of the geopolitics in Europe and East Asia.
Yeah, I think I'd kind of pose that question tongue-in-cheek, because when you look at the billions that are being invested in North America reshoring and the small crumbs that are happening in Europe, I think we're going to be lagging. But I think it's also too late to do anything about it. So we've seen IoT, smart cities, AI. Obviously, we've got a big drive in Europe on e-cars, EV charging, and everything around. But what do you see the highest demand for the semiconductors as we move into the next 2-3 years?
I think power efficiency and power management. As we mentioned there, EV charging and efficient charging, we're limited in terms of the raw materials that are available to build batteries. And as an EV reaches its usable life, or the battery in an EV reaches its usable life, you've either got to change that out or find a technology that gets the most out of that existing cell. And it's certainly cheaper and less damaging environmentally to get the most out of what you already have. And I know that my colleagues in Power, so Rich Ford, is talking to a very interesting line now about battery management. And for us, it's about efficiency in high power switching. So we're speaking to a company called Wise Integration, who we signed very recently on high frequency switching. And again, it's about driving efficiency in charging. So that's not only in EVs, that's in charging your personal laptop. You used to get in the middle of the cable a block that would get particularly hot. All that heat is wasted energy. And now we're seeing that those are disappearing because it's being managed at what is ultimately a microcontroller level. So it's silicon managing how that power is being used.
I mean, it's good that you touch on, because it segues quite nicely into sustainability. I mean, it's such a key driver. Our industry can do more, I'm sure, but we're also the leading force. So you talk about cobalt, lithium batteries. We're going to get to a tipping point where there's a lot of batteries that no longer are in circulation. What do we do with it? And I know that there's a technology drive to look at an alternative source, but semiconductors in particular, what's the sustainability view there?
That's a very difficult one. I think it's more around the energy generation, because it's no secret that a wafer fab uses a huge amount of energy, not necessarily, in the production itself, but also in all the HVAC that sits around there to keep those clean rooms clean and dust and pollutant free in the air. That requires a huge amount of energy. So actually generating it from renewable sources is one of the really interesting points. I mean, we're probably better. I'm delving into the realm of my power colleague.
You're being a politician here, aren't you?
No. Into the area of Rich Ford, our technical BDM on power, who knows much more about this.
And I know that that's an element that we can affect, the power consumption and more efficient power usage. But I also think that there is a huge problem with e-waste.
Yes.
And that needs to be. But anyway, we could be there. That's a whole
We're
different.
Slipping into a politics.
That's
podcast.
a different podcast.
Apologies.
So a question that one of my favourite podcasts, High Performance, they generally ask questions about what would an 18-year-old Simon Brennan, what advice would you give to him? 3 elements of advice to succeed in the semiconductor industry today and beyond.
Learn, and learn. I'm not an engineer. I didn't train in that background. I've trained at a manufacturer. I've learned the trade, being in front of customers and talking to people, and surround yourself with people who know more than you do. Ask questions, and that old phrase, there is no such thing as a stupid question. I honestly believe that with all my heart. If you don't understand it, ask.
I have a stupid question for you in a moment, but so learn, absolutely. I'm a big advocate. Every day is a learning day. Where can an engineer graduate find that learning repository? Where can you find that?
I think you've got to surround yourself with people who have been through that process. And we've talked about it. We see it in the UK, where actually there's a huge move to remote working, and that supports a lot of the industry now, and it's necessary to retain good staff to give them that option. But actually being around people who are more experienced than you and ask them questions. And you can do that over Teams, and you can do that remotely. You can do it in chat forums and online. But you can't believe everything you read in here, but you can see it when it goes wrong in front of you. You learn by getting stuff wrong, and that's okay.
So I get that, I do agree. And I think that building that engineering community and, learning from your peers, but also there's some experienced heads who are more than happy to share from their learning experience. So where does AI come into learning with a semiconductor industry?
I think it's a brilliant tool. We've talked about the demands it puts on component supply, but it's a brilliant tool. You can't trust it 100%. I think that, you can't go into it and blindly follow it, but use it. It puts together what seems like the most plausible answer based on the evidence available. So it can read far quicker than you ever can. It can collate data and give you an overview. And that's going to be, very, very accurate, but it's not going to be right in every case. So ask it questions. And I think we as people in the tech industry need to learn how to get more out of AI. Ask it better questions, and then you're going to get better answers back. Yeah,
it's a very good point. And I think the more we get to understand it, the more we'll not understand it.
Yeah.
Okay, my stupid question, of course. You're a pretty good golfer. Without telling everyone your handicap in case we play anyone for money in a pairs match. So the weather's shocking. What customer destination are we going to play golf next?
Oh, there's a list as long as my arm, but you can never beat Scotland. You get all 4 seasons in the summer, you get them in the winter as well.
Yep.
Links golf's beautiful, but it'd be nice to play in shorts and T-shirts somewhere, wouldn't it?
It would. Okay, I think we're going to wrap this up. That was quite insightful. Good luck with the new role.
Thank you very much.
Good luck with the tariffs. Yeah. Thank you, Simon Brennan, Semiconductor franchise manager, shit golfer. Okay, well, thanks for tuning into the podcast. It was the very first one, lots to learn. Hopefully some of the discussion points resonate with you. Any ideas, any topics you want to cover, let us know. Follow us on YouTube, LinkedIn, Twitter, Grindr, anything else that Simon's on. He'll give you his private address as we close out.